Polymorphism and dynamic dispatch at runtime. So polymorphism is one of the key benefits of inheritance, and it is also a frequent source of exam traps on the OCA. Consider the statement animal A. Consider here the statement animal A is equal to new dog, right? Here a parent reference, that is animal, it points to a child object dog. The reference type determines what the compiler allows it to access, while the actual object type determines which method implementation runs at runtime. This behavior is known as dynamic dispatch or virtual method invocation. For example, when you call a.speak, the compiler checks that the animal class defines a.speak method. Since it does, the call is allowed. At runtime, however, Java looks at the actual object type, which is dog, and calls the dog version of the method. As a result, the output would be something like dog barks. So fields behave differently. Java does not apply dynamic dispatch to fields. When you access a.name, the compiler resolves the field based on the reference type, which is animal. Therefore, the animal version of the field is used, right? Even though the actual object is a dog. So this is the difference between method behavior and field access, and this is a common exam trap. So if you see the code here, animal A, new dog, this one line is the foundation of polymorphism in Java. The reference type is animal, that is what the compiler sees. The actual object in the memory is dog, that is what Java sees at runtime. So hold both these facts in your head as we look at each access. Okay. So we see method call a.speak. So it will lead to dog barks. So compiler checks, does animal have a speak method? Yes. The call is allowed. At runtime, Java looks at the actual object, okay, which is a dog, and checks whether dog has overridden speak. It has. So dogs it has. So dog's version it will run, right? So output is dog barks. So this is dynamic dispatch. The decision of which method to run is made at runtime based on the actual object, not the reference type. Even though a is declared as animal, the dog speak wins because the actual object is a dog. Okay. So next one is system.out.println a.name, right? This is different. So this is a trap, and a.name looks similar to a.speak, but behaves completely differently, right? So fields are not subject to dynamic dispatch. When the compiler sees a.name, it resolves it immediately based on the reference type, animal, right? It finds animal's name in the field and locks in that access at compile time. At runtime, however, the actual object being a dog makes no difference. Animal's name field is what gets accessed, okay? So output is animal and it will not be dog. So what dog has done with string name dog is called field hiding, declaring a field with the same name as parent. It does not replace the parent's field. Both fields exist independently, okay? So which one you get depends entirely on the reference type, not the object type. And casting to access dog field is you see dog D, then dog A, right? Dog casting A, and system.out.println d.name, right? Now the reference type is dog. The compiler resolves d.name against dog's field definition and finds dog's name dog. Output is dog. Same underlying object as before. We cast A to dog and no new object was created, right? But the reference type it changed, so the field access resolves differently. And the asymmetry that you need to understand is that this is the most important distinction in this chapter 7. Same variable, same object, but methods and fields play by different rules. Okay. Then we come to final class, preventing inheritance, right? So when the final keyword is applied to class, it means that the class cannot be extended. Any attempt to create a subclass or of a final class results in a compile time error. A well-known example is the string class in Java. It is declared as final, which ensures that its behavior cannot be changed through inheritance. This design choice helps maintain the consistency and reliability of how strings work in the language. Okay. So when final is applied to a method, the class itself can still be extended, but the particular method cannot be overridden by the subclasses. So let's come to the code here. So we have a final class utility, static void helper, and class extends utility, right? So it will lead to compile error. Why? Because when final is applied to a class, it means that the class is complete and it cannot be extended by anyone. Any attempt to extend a class is immediately a compile time error. Okay, so utility is final, so extended class it tries to extend it and the compiler rejects it on the spot. So next is we have class myStringExtends right? So that's also a compile time error. String is declared as final in Java standard library. You cannot extend it. This is intentional and important. Java relies on string being trustworthy and predictable everywhere, right? So if string were not final, someone could create a subclass that overrides equals, hash code, or any other method, breaking assumption that the entire platform depends on, right? And so making string final guarantees its behavior that it can never be changed by subclassing. This is why strings are safe to use as hash map keys, safe to share across threads, safe to pool. Final is what makes that guarantee possible. So next is class base final method, right? It cannot be overridden. Then we have this class base, and then the class child extends base, right? And there in the class base we have final void do work, and in the child class we have void do work, right? That will also compile time error. Final on a method is narrower than the final on a class, right? The class itself can still be extended, but as child extends base successfully, right? But the specific method marked final is logged. Child cannot replace it. So child tries to declare its own do work. So compiler sees the parent's do works is final and ejects the override immediately. So we have understood the difference between a final class and a final method here. Okay. Now we come to the practice question, right? So we have a class vehicle, then class car extends vehicle, and public class test. There we have the public static void main. So question is, what is the output, right? So here if we see the output actually is answer is B, car, and then vehicle, right? So how it is so here if you see the setup, we have vehicle v is equal to new car, reference type is vehicle, actual object is car, okay? And then we have v.describe. Describe is an instance method, and car has overridden it with @override. The compiler checks, does vehicle have describe? Yes, the call is allowed. At runtime, however, Java looks at the actual object car and finds car's describe method and runs it. So runs it. So there inside that car's describe method we have system out the printer then car plus type. So what now which type does this refer to? We are inside car's own method. So the implicit this is a car object, right? So car object type here refers to car's own type fields car. So output is car : car. And the second call is v.type, right? System out.println v.type. Now type is a field, not a method. So fields use compile time resolution based on the reference type, right? So reference type here is vehicle. The compiler resolves v.type to vehicle's type field vehicle. The actual object being a car, it will not make any difference, okay? So output will be vehicle. So answer is B. Answer is B, car : car, and then vehicle, okay? So if you want to practice more questions like this, so you have to go to javalearn.clustermicro.com. There you'll find 1624 questions, and there are almost 100 questions that are free, and you have a trial period also. These are timed exams and that simulate real certification test. You have 29 full-length practice tests there, and this is a fully cloud native platform. Thanks for your time.